Okay, here we are, my friends. We're back with this Sub-Zero 430 wine cooler. And if you watched part one of this video, you'll know that we went through some preliminary checks. But I just want to reiterate. I want to go over some of the things we talked about. This refrigerator or this wine cooler has been sitting here now for, I'm going to say, 3 or 4 hours. The pressure has not balanced out. It's about 85 on the high side, and it's 25 on the low side. So, obviously, the Freon refrigerant, if there's any in there, is trapped. It's not flowing through. So I have this device, this harness that I made up. Let's see if it's up here. It is. What this allows me to do is I could hook this into the power cord and run the compressor and all the electronics and both valves just by hooking this up. So right now I'm thinking that because the pressure has not balanced out, that we have a restriction somewhere. So what I want to do is I want to turn it on first and then open up both valves and see if the pressure balances out. This is a cord I hooked up just for this type of work where you can bypass and hook everything in direct. Okay, so now we got power here. Now we want to hook it into the system. Okay, so now we can turn this back on, and then these two are for the valves. Okay, so now the unit's turned off. I have both valves energized. Okay, turning it back on. Pressure just kicked in. Both valves are open. I have them jumped up here. But the pressure still has not equalized. So what did we learn in school? We learned in school that if the low side is low, the back pressure is low, and the head pressure is low, then we have a leak. If the back pressure is low and the head pressure is high, we have a restriction. This is a little different. So what we're doing here is we're trying to find out if we have a restriction or we have a leak. And so I've pressurized it a couple of times. I've added Freon to it, and it's still not responding. It keeps going back down into a deep vacuum. So what do we do about that? Well, I think what we should do is we should remove the refrigerant, whatever refrigerant we have in the system, and see how much refrigerant you pulled out. This takes about 5.5 ounces. And I'm probably added 3 or 4 ounces in the process of diagnosing it. So let's do that next and see where we get. Okay, let's let that run for a while. Let's see how much Freon we pull out of there, and then we'll go from there. Okay, it looks like we're emptying out. At least the high side's down. So let's shut it off and see how much Freon we pulled out of there. Feels heavy. Let's see. Well, we got 5 ounces. So it's 1, 2, 3, 4, 5. Now this unit takes 5.5, and I probably put at least 3 or 4 ounces in there. So I know these hoses are long, but I think we're going to check for a leak just to be safe. I'm going to get the nitrogen tank. Okay, nitrogen tank is hooked up. We're going to pressurize both sides of the system up to 200 on the high side. And we're up there, let's see, 100, maybe 150. So let's open both valves. Okay, I'm going to have to hook up my ultrasound. I'll see if I can do that while I have these headphones, this camera on my head. Yeah, I can hear out of my left ear. These things are pretty sensitive. Now, it's recommended that you wet the area that you want to check for leaks, because the sound of the air leaking out will expand or increase, and you'll be able to find the leak. And I will spread or squirt some water on here, but first, this is the normal way I check for leaks. Okay, I think the upper coil's good. Oh, I hear something already. Right there. See the light? Right there. Okay, I don't see anything. I think it's, you see where that green oxidation is? That looks like, let me get a light. Look at that light. I hear it, but I don't see it. You have to verify, so you have to see it. That's the way I work. There's a bubble right there. I don't know. Right there. See the bubble forming? It's making a hell of a lot of noise. You would think that the leak was bigger. I could pull the evaporator away from the wall. Maybe get behind that tubing. What are we doing on pressure here? Yeah, got a lot of pressure in there. Well, there's the bubble forming right there. And that's where I'm getting a really loud response here. Right there. Not there, but right here where the aluminum fins touch the... Yeah, you can see that bubble forming right there. It's a really slow leak. Let's see if we can get it to do it again. It's already forming a bubble. Another bubble forming right there. Alright, this unit has a leak, so the next thing we're going to do is replace that evaporator coil. Now these evaporator coils are the same evaporator coils they use on the 561s, and I happen to have one of those around. So we'll change the coil, we'll pull a vacuum, we'll pressure test, we'll charge it up according to factory, which I'm pretty sure is 5.5 ounces, and then we'll button up this job. Okay, we are back here now. We allowed this refrigerant to empty out, the nitrogen to empty out. We're going to replace that evaporator coil. That takes a 420 4440. It's the same as a 561. Before we do that, we're going to remove both of these line tap valves. We have a new dryer. We have a process port for the low side. So let's get started. Let me take these valves off first and then we'll come back. Okay, so here's where we're at. I got this filter dryer prepared. We're going to hook this in like this. And we're going to solder this into there. We swage these out, all these lines, because I didn't have the exact dryer. This is this was for a 424 wine cooler. Obviously this one is a little different. It had 1/4 inch swaged out on the ends for 1/4 inch tubing. So this is all I had. So we'll use this one for that. And I also going to put this process port on the low side right there, like that. So let me get that set up and then we'll move on. We wait for it to glow red, and we'll know it's hot enough. Okay, let's let that cool down and then we'll connect this one. Make sure you remove the Schrader valve before you start soldering. Otherwise you'll melt that little nylon seal in there. The tip of the flame is the hottest part, the blue. Just touching the tubing there. And you only need, on a 3/16 line, you only need 3/16 of an inch tubing, so you don't need solder. You don't need a lot of solder on this. I see some guys, they just keep putting more and more solder in there, and they wind up blocking the line. And I always like to point it down so the solder doesn't flow up. Okay, let's let that cool down, and then we'll work on the evaporator. Careful, you don't want to drop that screw down in that drain. Alright, so now I'm going to pull this up. Alright, so I use these aluminum clothespins to hold that up. And you can see it's not holding because they've lost their spring ability there. Alright, so we're going to get the new evaporator, part number . Okay, so the instructions say on a 430 wine cooler, prior to serial number 237, charge amount 5 ounces. This is a 2004, so we're going to charge this with 5 ounces instead of 5.5. Okay, so now we could see how much tubing we're going to have to cut off there. So we're right at the bottom of that clip there, that clothespin, is where we want to be, somewhere in that area. But we could actually make it longer because we could always just bend the tubing a little bit to compensate for that. So we're going to cut it around here and prepare it for solder. Okay, that's off. And supposedly this tool is advertised. You can cut cap tubes without damaging or squashing the tubing. But I don't know about that. Yeah, it's not bad. I've seen better. We can clean that up a bit. Alright, so let's prepare the tubing for solder and clean out everything. Now these new evaporators are, you probably know this, are one-piece aluminum, which are a little bit more efficient. But the copper tubing that they attach on here, right here, these are called blast joints under high pressure, and they merge the atoms of the copper and the aluminum together, and that creates a blast joint. I think it was developed by GE, but I'm not sure. Maybe somebody out there knows for sure. And this is the most common place for these things to leak, the blast joints. Alright, so let me get that insulation out of the way. Okay, so I like to use a 16 gauge wire cutter. That's what I've been normally using for so many years, and that usually gives me a nice clean cut. See, it's just enough to score it. There you go. Now let's look at that. That's a little better. Okay. Now I'm going to put some flux on there. Just in case you people don't know it, you techs, but according to Donald Trump, he's canceled a protocol for refrigerant upgrades and canceled the ozone. I don't know what they call it, but manufacturers can now continue to use 134A and not R600A. I'm getting a lot of slack from technicians who are telling me they don't like using it. I mean, you know, I don't get it, but in case you haven't heard, that's what it is. When you see the flux starting to bubble, that's a good sign that it's getting ready. Okay, that looks good. Well, let's cool it down. All right, before we hook it back up, we're going to do a nitrogen pressurization and check it for leaks. Okay, here we go. Just want to make sure I don't hear anything leaking. Always check everything, even the dryer joints. You never know. I mean, it's very rare that these things leak from the factory joints, but I've seen them leak. So just be sure, because you don't want to have a callback. Callbacks are very costly. Okay, it's looking good. We can button this thing back up and charge it up. Okay, it's all buttoned up. Evaporator's in. There's no leaks. The filter dryer's been mounted. This is what it looks like. So the next step is to drain the nitrogen out and pull a vacuum. Now I have to run on an errand. It's going to take me a couple hours. So we'll put the vacuum pump on here for a couple of hours. And then when we come back, we'll charge it up. Okay, so we're hooked up to our vacuum pump. And before you use it, make sure you check the oil level. And also, I like to pull the vacuum from both sides of the system, high side and the low side. So these are connected directly into this is the low side. So on my channel there's a video on how I rebuilt the pump, the vacuum pump, in case you're interested. You still get the parts from Robin Air. So this pump has been completely rebuilt. I don't remember how much it cost, but it wasn't that much money. So I got to hook this into here and raise this up a little bit. Now I'm going to turn it on, hook up the other side. Open up the valve. All right. We're now pulling a vacuum. We're going to let that run probably a couple hours. So I have to run some errands, as I said before. So we'll let that see what happens, and we'll come back and check it out. Okay, we ran the vacuum pump for a couple hours, just got back. The machine is on. I'm going to charge it up now with 5 ounces of 134A. So let me get that ready in my charging column here. Well, we had 5 ounces in here yesterday when we took it out, and now we only have 3, which means that charging column has got a leak in it. And that means that's another thing I'm going to have to fix. Fortunately, I still have one of these rebuilding kits here for the charging column. They don't make these anymore, but hopefully that one will last me until the end of my days. Alright, so look, we need 5 ounces in here, and we have exactly, let's just double check. Now this is an R22 scale, but I'm using it, I've already measured this, so it's 1, 2, 3, we have about 3.5 ounces in there. We need 5. So I'll hook this up to here, open the tank, and then invert it, and hope we get a transfer. Okay, we have 5 ounces. Okay, we are just about done here. All we need to do, compressor's running. So let's open up the gauge here, and we've got 5 ounces of 134 measured into that column. And there we go. Always charge it vapor. Never put liquid in the system. Let's that charge up there, and when that's done, we'll just button up the job, make sure it's working. In the meantime, I'm going to get this new Northland condensing unit up on the bench. Okay, we got all the Freon in there. Back pressure's at 10 psi. Temperature right now 64, 67. And let's let this run. Make sure it pulls down. Okay, looks like we're good to go here. Running at about 10 psi. We got temperatures pulling down. I think both sections are set at 54. Let me see. Here we are here. 53, 54 it was set at. Yeah, 54. So we're down to temperature. I'm going to consider this machine fixed. So I'll put the top back on and button it up, and then we'll get on to our next project, which is going to be this Northland just came in from Michigan. It's got a bad compressor, but it also has oil in the drain pan, so that means we have a refrigerant leak, which is probably why the compressor went bad. I'll be in touch on another video.